Hi and welcome back. Let's try question 2, where we have to use first principles to determine the derivative of y equals 1 on x squared with respect to x. Step 1 is to write out our limiting chord or derivative by first principle formula, which we know dy by dx is given by the limit when h approaches 0, f of x plus h minus f of x all over h. Okay, and we're told that our function y, or f of x, is 1 on x squared. That means that f of brackets x plus h is 1 on x plus h squared. So what we've done, wherever we see x in this equation, we replace it with x plus h. Okay, now we have everything to sub in our formula. For x plus h, we're going to sub in that. For f of x, we're going to sub in this. Okay, so our derivative as h approaches 0 is f of x plus h, which in this case is 1 on x plus h squared. Take away f of x, which is 1 on x squared, all over h. Our next step is to work out this. We're going to subtract a fraction, and we're just going to use this rule. Okay, so if we've got a fraction minus another fraction, in order to subtract fractions you need to have a common denominator. To do this easily, you could cross multiply, so you could do that times that, take away that times that, all over the numerator that times that. Okay, so let's do that again. We're going to do the top times the bottom, and so we get AD minus that times that, CD, all over that times that, BD. So in this case, our derivative as h approaches 0 is that times that, which is actually just x squared, minus that times that, which is x plus h in brackets squared, all over the numerator times the numerator. So you have x squared x plus h squared, and all of this is on h, which in fact I'm going to write as divide by h. Okay, so let us expand the numerator of this and simplify. So our derivative as h approaches 0 is x squared minus, and if we expand this brackets we get x squared plus 2xh plus h squared, all over x squared x plus h squared, and remember the whole thing is divided by h. Now we're going to multiply this neg out by all of these, and so our derivative as h approaches 0 is x squared minus 2xh minus h squared, all on x squared x plus h squared divided by h. Now we could collect like terms, so these two actually cancel each other out, and so we're just left with this part, and we could factorize that as well. So we could take out a negative and a h. So our derivative as h approaches 0. If we take out negative h, we're left with 2x plus h. That's still going to be over x squared, x plus h squared. And to divide two fractions, we could just make this over 1. We could actually flip these two around, and then the division becomes a time. So we have 1 on h. Okay, so we flip this fraction around, and the division will become a times. And then this h actually cancels with this h, because we have a h on the numerator and h on the denominator. And so our derivative as h approaches 0 is negative brackets 2x plus h on x squared brackets x plus h squared. Okay, and now we could apply this rule. So as h approaches 0, so basically we could put 0 there and 0 there. Our derivative dy by dx is, we're left with minus 2x on top and x squared multiplied by x squared, which is x to the power of 4. And that simplifies down to minus 2 on x cubed. So the derivative of 1 on x squared is minus 2 on x cubed using first principles.